this is one of those figures that I told you yesterday. If you have something that's closed off, it's going to be to your benefit to actually make them look like lines that intersect each other. And sometimes it helps to turn your paper. It helps some people that get the angle pairs confused to always make sure that their parallel lines are horizontal. That might require you to turn your paper. That's fine. You can always turn your paper upside down, sideways, whatever works for you. Even when you're on the SAT and things like that, you just turn it whichever way you need to make the picture make sense and make it work for you. It's totally fine. So we have our lines that are labeled parallel. So I'm gonna extend those and actually make them lines. There we go. So I have two lines, right? Which means I then have two transversals, okay? And I need to be able to set something up to solve for x and solve for y and be able to explain myself as I do it, okay? Are these two angles here, these two right here, are they same side interior angles? Yes. So can I add them together and set them equal to 180? I could. Would I be right if I did? No. Why? Because if I'm using these two angles, I'm ignoring this line, right? They're not parallel. Does that make sense to you? These are same side interior angles. These are not supplementary because these are my parallel lines. So I have to use my parallel lines, and then I need to pick one transversal at a time. I may need to use them both, but I can't use them both at the same time. So if I use my two pink lines and then I use maybe this line here. Okay, so there are my three lines. I have two lines cut by a transversal, two parallel lines cut by a transversal. So those three lines have nothing to do with these two angles down here, right? Because that would mean these two angles here, they're same side interior also, right? But they're not supplementary because if I add them together, I don't get 180. You can see right there with the numbers. Okay, but then I do have these two angles that are related to this set of three lines. And what type of angle pair are these? Same side interior. Are these supplementary? Yes, because our same side interior angle is always supplementary. No, only when the lines are parallel. Okay, so you can name them same side interior, but they're only supplementary if they're related to parallel lines. And this down here completely gets ignored. So these two right here, am I going to set them equal to each other? No, because you just told me they were same side interior. So I'm going to add them together. 96 plus 2x equals 180. Okay, and then I have to have an explanation that goes with it. So I'm going to say that this is if two lines are parallel, then same side interior angles are what? Supplementary. Okay. Everybody okay with that? All right, so can I solve for x? Yes. So this means that 2x is going to equal what? 84. So x equals 42. Is it 42 degrees? No, because once I put it in there, it becomes degrees squared and doesn't make any sense, so it's just 42. All right, so there's that. I still have to find y. So I can use this transversal, still have to use my pink lines, right, because they're the parallel ones. I'm going to use this transversal, which means I ignore this stuff. I can't relate these two to each other or these two to each other. They're a special angle pair, but numerically they don't mean anything. So what type of angle pair is this? Same side interior. Okay, so I can add them together. So 94 plus 3y plus 44 equals 180. All right, so that means that 3y plus what? 138 equals 180. 3y equals 42. Okay, just pause here, a little side note. One of the mistakes I saw in the test kind of over and over again is if it had, not really with 180 minus 138, but like if I'd had something like 180 minus 38, there was people giving me 42. Because I think you were so focused on what to do with these, you kind of forgot the 100. Like here, the 100 gets subtracted off, but just be careful with that. That's why if you actually think about it in pieces and actually subtract in pieces, you're less likely to just lose something off of there. Okay. But in this case, 3y does equal 42. So y equals what? 14. Am I missing anything from any of this? The explanation, right? Here, you see how I explained it right after I set it up? Because then I don't forget. Right? You set something up and you just solve it, you're likely to either forget to even do it or be confused about what you're even supposed to write. But the reason you knew that you could set this up is because if two lines are parallel, then same side, interior angles are supplementary. So your explanations are important. Everybody okay with that? So let's look at this one. What was your question going to be? Right, exactly. So when you're done, then you should ask yourself, am I done? And the only way you know for sure is if you go back and read it, and that's why you said never mind, right? It just says value of the variables, so I don't need to plug it back in. Now, if you wanted to check yourself to see if things actually worked out, then you could, but you don't necessarily need to. All right. So this next one says, find the value of the variables in the figure. Explain your reasoning with postulates and or theorems. Okay, so I want you to take a minute to kind of look at this picture. See if you can make it make sense to yourself. How many lines does it take to create this picture? 4. Are x and 105 a special angle pair? Yes, no, maybe? That angle right there? Okay. So, since it takes 4 lines, that's not just one continuous line, right? How many sets of parallel lines do you have? Just one set of parallel lines. So I can only use one transversal at a time to figure my angles out. And that x is created by both transversals, right? So it's not going to be just straight up one of the same angle pairs that you've had before. There's 2 different ways to approach this. One of them includes drawing in a random line, which I think is not something that you always think to do or that you can do in situations. So I don't think that's really the best way to show it. I mean, I think maybe I'll show it after we do it. But really, it's better in any of these cases that if you have a situation where you're going to use parallel line rules, which is clearly what we're going to do here, is that you actually make everything you have look like lines. So I'm going to come in here and I'm going to extend this one and just make it actually be a line. And I'm going to extend this one and actually make it be a line. Because then you're looking at it more as actually 2 parallel lines cut by a transversal, and you don't have that weirdness going on right here that doesn't really mean anything directly. Okay, everybody okay with that? All right, so then we decide, all right, we've got to just look at the 2 parallel lines and 1 transversal at a time. My goal is to get x. X is not going to be same side. I mean, it might be one of those angle pairs depending on which lines I looked at, but not when I use my parallel lines and my transversal. Because if I use the 2 parallel lines and this purple transversal first, that means I just completely ignore the green one, which means x kind of goes away, right? So I've got to figure out what I can know and what I can label so that I can get something that would help me get x. So what would be the most helpful thing, do you think? Yes, ma'am. Okay, if I ignore the green line, x doesn't even exist anymore, though. Does that make sense? Like when the green line goes away, x just doesn't even exist. Like if I could erase it, I would. But do you see what happens? Because the x is made by the green line and the purple line. If one of them goes away, the angle doesn't exist, right? Which means I can't find the angle directly. Does that make sense to you? Like I can't just do something, bam, that's x. So I got to find some stuff. Sometimes you have to find stuff they didn't ask you for to find the stuff they did ask you for. Yes, ma'am. Okay. Okay, we could. And if like all of this right here, is that what you're saying? Okay, I could do all that. Is that going to give me x? Use the same idea though. What could I, don't even worry about what you're able to find right now. What, if I was able to give you one thing that could help you find x, what do you think that might be? And it could be, I mean, there could be more than one answer to that, but, well, the value of x, yes, but I'm not giving you that. Okay, x is a vertical angle. So if we knew that one, that would help, right? Okay, so that one, I have the same kind of situation then. I mean, and these are congruent, that is true, right? But I kind of have the same situation there. So I'm not going to give you that one. What else could I give you that could help you find x without me basically telling you what x is? This one? Let's see. Okay, but you can find that, right? What could I give you? What else? Look right at x. Okay, well, yeah, you're trying to use some parallel line stuff, but parallel lines aren't related to that x right there. What angle measure could I give you that wouldn't just tell you x, but then you could do one thing and find x? What? The supplementary one? Because what type of angle pair could I make with x? A linear pair. So if you had this angle or this angle, and those are congruent, right, because they're a vertical angle, if you were able to find this angle, could that get you x? Okay, so let's see if maybe we can find that angle, right? So maybe our goal needs to be, okay, yeah, I need to find x. I can't find that directly. I wonder if I can find this one right here. All right, well, look at what do you have there that you have seen before that you might be able to use to find some measurements? Let's start finding some stuff. If this is 125, what is this? 125, right? Okay. If this is 125, what is this, or how do I find it? Subtract it from 180, so what would it be? 55. Okay, so this is 55 there. It's kind of small, so I'm going to label that. What? Okay, so this has to be 55 also, right? Okay, so I have that this is 55. Does that 55 possibly help me find this angle that I need? Yes? How? This is a vertical angle. But how is this angle going to help me get this? What kind of information could I use? Tushar? Well, you were stretching, so now you have to answer. You have any ideas how that might help me? What else could I find that would still help me down here get this? Okay, what's the 105 going to give me? Alternate exterior, so it could give me this one, right? That would be your alternate exterior. This 105, could that give me this angle right here? And that is 105. It just doesn't really fit. What's the measure of this angle? 105, because those are corresponding angles. You agree with that? Okay, so now I can find this one here. What's that going to be? 75. Now can I find that angle that I have marked with 2 marks on it? How? There you go. You have to make sure when you are looking at problems that you don't have tunnel vision, that all you're thinking about is parallel lines, because we've been talking about parallel lines. And that's all that's on your brain is parallel lines. Because, yeah, there's parallel line stuff that I'm using, but this right here is a triangle. The 3 angles in a triangle have to add to give you what? 180, right? Does that make sense? And you've known that for a very long time. So this is x. We're going to call this right here that we're looking for y. And then I'm going to redraw this because it's also tiny. So this is y. We have found that this is 55 and this is 75. Right? That makes sense to you? So now we use triangle knowledge that's not new stuff, right? And we know that those 3 angles have to add to give us what? 180. So here's what you don't do. You don't say, well, I'm gonna add those 2 together and then subtract from 180, because that isn't a rule about nothing. Okay, will it get you the right answer? Yes. Will I count it wrong or at least take points off? Absolutely. Because what you will say to me is that the three angles have to add to give you 180, because that's the rule. And that's what you need to do, is add them up, set them equal to 180. So y plus 75 plus 55 equals what? It equals 180. Okay? You add the three up, you set them to equal to 180. First step, zero work. That's what you know about triangles. Then you add these two together, and you get what? 130. So y plus 130 equals 180. So y equals 50. Okay. Everybody okay with that? Okay, so that means that this is 50. Am I done? No, I made up y, right? I could have called it z. I could have called it anything but x. Nobody even asked me for that, but I needed to find it. Now can I find x? Yes. What type of angle pair is this? Linear pair. So I know then that basically x plus y equals 180. We know what y is, so x plus 50 equals 180. Oh, 180. So x equals 130. Okay. Extend your lines. Find what you can find. When you're stuck, that's one reason I didn't lead you through it too much. When you have all this, and you're like, I don't even know where to start. Start finding stuff, right? Did I even really need, I could have found, I didn't need this 105 right here. I didn't need this 55 right here. I didn't even need this 125, but we didn't know that at the time. So you just start labeling what you have until something starts to make sense, and you go, oh, well, if I know that, then I can find this, right? Just start labeling everything you have. We could have labeled absolutely everything if we'd wanted to, but make sure you're paying attention to where your parallel lines are and your transversals are, okay? So I'm going to show you the other way to do this, which I'm not a huge fan of. It may look a little easier to begin with, but it's something that is not always handled in the right way. So I'm just going to attempt to redraw this in the best possible fashion. You don't have to write this down, just stay with me. And this is 105. It does seem easier from the get-go, but I'm telling you right now, you're not going to remember when you're allowed to draw in a random line and when you're not. Oh, dang it. You can't even swear? Okay. Is that correct? Okay. All right, and then these are parallel, right? Okay, so what we're going to do is we're going to draw in what's called an auxiliary line. That just means it's a line that's not really part of it, but that's legal for you to draw in. So I'm going to draw this in, and I'm going to say that this is parallel. How do I know it's parallel? Because I drew it in with the intention of it being parallel. Okay, so that's all fine and good. Now I can use these transversals that I have to find x, but I still can't find x directly. What I know is if this is 105, this is 105. So what is this? 75. So does x equal 75 degrees? No, but part of x does, right? And then if this is 125, this is 125 because they're corresponding. And then that makes this right here 55. And then I can add those two together. I know that may seem simpler, but that's because I talked you through it. The other one, I made you struggle through it. If I'd have kind of talked you through it as we went, we could have gone through the other one a little quicker. I think it's really better to label what's there than to draw in something random. That's different than extending a line, because then you're going to think you can draw in random lines everywhere you can. Okay, and they're not always going to help you, very rarely, but that's just another way to look at it. If you can handle it correctly, I don't have a problem with it, but I've really seen more kids get confused with that than anything else, so I thought I'd throw it out there. All right, any questions? Okay, if you haven't glued it in, go ahead and do that.